Dear all, in this session, I would like to have a brief review on the question paper for the subject Basic Electrical Engineering, which has happened in the year of June-July 2023. So we'll have a brief discussion. What and all the questions are asked, what about the topic they covered, all the parts we are going to discuss. We'll be having a brief discussion. Okay, so that you will be understanding how to prepare for the forthcoming examination. Let's see the question number module one, question number 1A. So state and explain Kirchhoff's current and voltage law, KVL and KCL. You can explain with the help of some suitable diagram with a suitable example. For example, it's whenever you are talking about like so if you want to have like a KCL, okay, let's see like a KCL, you need to use the formula sigma I. Okay, so net current meeting at a junction that is equal to 0. If I talk about KVL, you need to mention the equation. The for a closed loop, the voltage drop, sum of voltage drop and the EMF that is equal to 0. It's applicable only for the closed loop. Okay. So another question, determine current in all branches of the network which is shown in Q1B. Here you can apply both KVL and KCL. Okay. KVL and KCL you can apply. Definitely you can find out each case. You have to find out, you have to make like say this is I is equal to 30 amps. Okay, here you have to decide the direction. Each cases you have to decide the direction, compute. Okay, you need to compute the value of current that you are supposed to do in question number 1B. If I talk about question number 1C, define RMS value. Okay, you have to write the definition of RMS value. So you need to reach the definition. So for example, IRMS, IRMS equal to IM by root 2, or VRMS, VRMS equal to VM by root 2. This expression you are supposed to reach. Okay. So definition with a suitable example you have to explain. So that can be done. Another question is actually state and explain the maximum power transfer theorem. Here you'll be getting like if you go for like a definition, you'll be getting 2 marks plus proof, brief explanation that is sufficient, but it's a condition for PM that you are supposed to derive. Okay, like PM is equal to E square by 4 into R. This condition you have to derive. So that's important. Moving on to the further discussion. Then question number 2B, if the total power dissipated in the circuit is 18 watts, so we can write a total power of P is equal to 18 watts. Then determine the value of R in the circuit. That's the first one. So you already know that P is equal to V square upon R. Here V is given already. How much? 12 volt. P is already given. P is of actually 18 watts. So we can compute the total resistance first. So that means 18 is equal to V square. V means 12 square. 144 divided by R. From this, you compute the value of R. R is equal to 144 by 18. You will be getting the value of R. Okay. Later, what you are supposed to do is you need to calculate the unknown value of resistance R. Here, you have to solve. Okay. 18 and 8 and R is already available. Similarly, 6 and 4 and 16. Okay. So as we can see, 8 and R is actually parallel circuit. 8R divided by 8 plus R. Then that is series with this combination. 4 into 16 divided by 4 plus 16. Okay. That is equal to the total value of resistance. From this, here you can substitute the same thing. Fine. From this, you can compute the unknown value of resistance R. Fine. So another question is the power consumed by 8 ohm resistor. So where it is this one? So P is equal to I1 square into 8. Here I1 you have to calculate. First, you compute the total current. Okay. So total current you have to calculate. But then by using the current division, I can calculate I1 using the current division formula. Current division rule. You try once. Still you are not getting, you can inform me. I can do it in the description box. I can edit. Okay. So please do let me know. These are the steps I am displaying for you just for the betterment. So if you understand the steps, you can solve it fastly and you'll be getting the accurate answer. Okay. So use the scientific calculator and follow up accordingly and try to understand the concept also. So question number 2C. So what is the meaning of question number 2C? So discuss about AC through pure inductive circuit. So the relation between voltage and current. Okay. Then you have to write the relation for the pure inductive circuit. V is equal to Vm sin omega t, where I is equal to Im sin omega t minus phi, where phi is equal to pi by 2 for ideal condition. Then here you have to prove the average power, P average is equal to 0. Use the integration. P average should be equal to 0. Okay. Those things you have to finish it off. So let me continue the discussion. So then question number 3A. That is also a direct question only. So in case of question number 3A, discuss the detail about AC through RL circuit. You have to calculate the circuit diagram. First of all, you have to calculate the RL circuit diagram, correct? Okay, draw the neat circuit diagram. You mention RL, then the total current I. Okay, then you have to study the relation between what about the voltage across resistor, voltage across then inductor, then draw the phasor diagram. After phasor diagram, you can derive the formula Z is equal to square root of R square plus XL square. Okay, then similarly, you can calculate the tan phi also. Okay, tan phi is equal to, you have to calculate opposite side divided by adjacent side. Okay, based upon that, you will be getting phi. Later, if you want, you can calculate in terms of power factor also, cos phi. So based upon that, there is one problem. Circuit comprises of 20 ohm resistance in series and 0.05 Henry inductance in again series. And the total supply voltage is given. Calculate I. Current is equal to V by Z. Okay. Z you know how to calculate. So that means V divided by square root of R square plus XL square. Let me know how to calculate XL. XL is equal to L omega, where L into 2 pi f. Supplies frequency is given. You substitute accordingly and compute. Similarly, you need to calculate the phase angle. You draw the phasor diagram. From that, you compute the value of tan phi. Thereafter, you can calculate the phi. Similarly, a power factor. Power factor can use the formula R by Z. Power factor cos phi is equal to R by Z. The on-spot answer will get. Similarly, active power. Equation for active power is, what is the equation? P is equal to VI cos phi. If you want to have the equation for reactive power, P is equal to V into I into sin phi, correct? So follow accordingly. Then another one is actually based on the AC circuits. Here you need to use the complex numbers. Okay, complex number you can use AC through impedance AC through the given circuits Z1, Z2. Okay, so kindly go through that. So now let me continue the remaining discussion, remaining part. So remaining sections are, I'll remove this. Establish the relationship between phase and line value. Okay, very important. Phase and line value of three-phase delta connected circuit with relevant waveforms. Also derive the equation for three-phase power. Okay, so here your expected outcome is equal to, in case of delta, since it's a delta connection, the line current is equal to √3 into phase current, where the line voltage should be equal to phase voltage. Similarly, there is a power derivation. So P is equal to √3 into PL into IL into cos phi. These are the things you need to reach the derivation. It carries the weightage of 8 marks. Briefly explain the advantages of measurement of three-phase power using two wattmeter method. Okay, that's also important. In case of 2 wattmeter method, the advantage is you can go ahead with the balanced and unbalanced load. Here you need to calculate the tan phi, then phi you have to calculate, then cos phi you have to calculate. So total power rating is equal to sum of W1 and W2. Okay, this concept also you have to remember. Okay, so remaining part I'm going to discuss in the coming session. So please stay tuned. Thank you so much for watching this video.